Okay, folks, so we have already gone over mole to mole in video 1. Video 2, we learned how to convert from mole to grams and grams to moles. So now we're on our last video of conversions for stoichiometry, which would be gram to gram. So I went back in and I rewrote those skeletons because I know that they were pretty nasty looking. And so I rewrote these. So you may want to take a second and just pause your video and rewrite these roadmaps or skeleton setups of how to work these stoichiometry problems. Today, we're going to learn how to go from gram to gram. So if you want to take just a second, and I'm going to go ahead and let you just copy all 4 of these little roadmaps for stoichiometry conversions. If you want to go ahead and copy those down real quickly, just pause your video. So today we will be starting with a problem where we're given a number in grams. We're going to have to convert those grams to moles by using molar mass. Then we will implement using the molar ratio. And then we will have to find the molar mass of our unknown in order to get our answer in grams. So basically, we're kind of meshing these two together, and you're going to end up with 2 molar masses that have to be worked out in order to get your answer, okay? So I just want to go ahead and let's work a few problems. We're going to work 2 problems on gram to gram, and then I'll show you where you can find those um, on the Google Classroom. Okay, so let's get started. So we're going to start with, if I can get my cameras adjusted. We're going to start with this chemical equation. Sorry about that, y'all. All right, so 10,2-fluoride is something that we see a lot in toothpaste. And in order for us to make 10,2-fluoride, we have to use the following reaction. So we're going to use 10 plus hydrofluoric acid to produce 10,2-fluoride and then hydrogen as a byproduct. Okay, so go ahead and pause your video if you would like to balance this out on your own. And to balance it, we put a 2. So this is going to be a gram to gram problem, which means that the given for this problem, of course, will be in grams. So they're wanting to know how many grams of 10,2-fluoride are produced from the reaction of 30 grams of hydrofluoric acid with 10. Okay, so here's my problem, and I'm going to immediately start by finding my known. So my given is going to be 30.00 grams of hydrofluoric acid. So I'm going to go write that up here above the hydrofluoric acid. And then they want to know how many grams of 10,2-fluoride. Now, I'm going to go ahead and tell you, some of y'all have probably been shortcutting it and not writing down this step right here. And I'm going to tell you right now, this is where it's going to come back and it's going to bite you. As I've said before, if I do it and I have a degree in this, then you probably need to do it as well. I don't have a lot of sympathy for students who miss problems when they skip these steps, because it literally takes you like a second to write that down. But this is going to allow you to see, this is what I'm given, this is what's my unknown. So that means this is a gram to gram problem. In our next video that we're going to do, we're going to look at when all these problems are mixed up. And that's where a lot of students have problems because they're not sure how they do it when they're all mixed up. Well, if you don't write down this, you're going to get really, really, really confused, okay? So let's go ahead and work this one out. So we're going to start with our given, which is 30.00 grams of hydrofluoric acid. And I need to find this, but to bridge the gap between this reactant and this product, I need to use the mole ratio. But I don't have moles here. All I have are grams. So I've got to convert to moles. So I've got 1 hydrogen, so that's 1.01 grams, and fluorine is 19. So that gives me 20.01 grams per mole for hydrofluoric acid. So I'm going to go put this in, and I'm going to put 20.01 grams of hydrofluoric on bottom and 1 mole of hydrofluoric on top. And that cancels out grams, and I'm left with moles of hydrofluoric. So yay, now I have moles of this, so I can use my mole to mole ratio. So I'm going to say 2 moles of hydrofluoric, and then that's 1 mole of 10,2 fluoride. So my moles of hydrofluoric cancel out, and I'm left with moles of 10,2 fluoride. But I need grams. So I know to get from moles to grams, I have to do the molar mass once again. So 10 is 118.69. And fluoride we said was 19. So since there's 2 of them, that's going to be 38. And then add that together. And that comes out to be 156.69 grams per mole. So I'm going to put my mole on bottom and 156.69 grams on top, and that cancels out. So now I run it through my calculator. 30 times 1 times 1 times 156.69 equals divided by 20.01 divided by 2. I'm going to do that one more time because I think I missed a button. All right, and I get 117.4588 grams. So I go and look at my given, 4 sig figs, 1, 2, 3, 4, 117.5 grams of SNF2, and that's my answer. Now, throughout the duration of this course, I have over and over and over and over again told you, be sure you write your units, be sure you write your units, be sure you write your units. I'm hoping that now it's kind of obvious why we need to write our units, because when you're working a problem that's as lengthy as this one, it's real easy to get confused as to what goes on top and what goes on bottom. So I'm going to tell you right now, students who write everything out are successful. And I always like to show y'all, this is some of my work. And you'll see that even on my work, I'm writing everything out. And so if I'm writing it out, you probably need to write it out as well. Okay, so that's just good practice, because we're going to add to this a little bit as well. And then when they get to be mixed up, it's very difficult if you're not sure where you need to stop. And so, if you were stopping at moles and you didn't write that down, you wouldn't know to stop. So it's important to write down all of our units. Let's do one more problem, and then we will go from there. Okay, so I want to make some iron oxide. So I'm going to combine iron and water to form rust. Okay. And then we're going to form some hydrogen gas on the side. All right, so take a second and let's balance this. You can pause it. Okay, and this balances it. Okay, so for this problem, they tell us that we have 67.0 grams of iron, and they want to know how many grams of this iron oxide we can produce. Okay, so let's start with our given. So we're starting with grams of iron. And of course, to bridge the gap, I need this to be moles. And to get it to moles, I have to do molar mass. So molar mass of iron is 55.85. So that's nice. I don't have to do any math there. And 1 mole of iron. So now I'm left with 1 mole of iron. So now I can use my molar mass. I'm sorry, mole to mole ratio. And I have 1 mole of the iron oxide compound. Okay. And then last but not least, I need to get this to grams. So in order to do that, I need to work out the molar mass. The molar mass of this is going to be 231.55 grams of Fe3O4. Okay. So now I'm going to just run it through my calculator. And I get 92.5924 grams. So 3 sig figs. So 1, 2, 3. So it's 92.6 grams of iron oxide. And that's my answer. Okay, so once again, on the classroom, when you get to the classroom, you're going to see this under classwork for Unit 6, mass to mass problems. And so right here, I've provided you with some practice problems. And then right here are the answers to those practice problems so that you can see how you're doing, okay? If you have any questions about anything, just feel free to drop those questions in the comments, and good luck.